If you need to validate LLM output, here's the production version of the problem. Your agent asks a large language model, or LLM, to classify a support ticket. You expect status to be open, closed, or needs human. The model returns pending-ish. Your code does not complain. It stores the value. The workflow sees a status it does not understand, retries the model call, gets another weird status, and now the ticket bounces all night. No dramatic failure, just bad text slipping past the boundary and becoming state. The beginner version is, tell the model please return JavaScript object notation, or JSON, then called JSON.loads, then trust the dictionary. That feels reasonable until the first real edge case. Maybe the JSON is valid, but the value is wrong. Maybe priority is urgent when your system only accepts low, medium, high. Maybe price is negative. Maybe start date is after end date. Parsing only answers one question: is this text shaped like data? It does not answer, is this data allowed in my application? Those are different checks, and production systems need both. The core habit is simple. Treat model output like a web form filled in by a stranger. Not because the model is malicious, but because it is probabilistic. It can be helpful and still be wrong. So the boundary rule is parse, then validate. Validate types: string, integer, boolean, list. Validate ranges: confidence between 0 and 1, quantity at least 1. Validate enums: only allowed labels. Validate cross-field logic: if action is email, recipient must exist. Only after that do you let the data affect databases, tools, workflows, or user-visible decisions. The build is one boundary function. First, define a typed model for the exact response you will accept. In Python, Pydantic is the common choice. In TypeScript, Zod plays the same role. One typed model becomes three things: parser, validator, and documentation for future you. Second, put all model output through parse output raw string to output or none. Third, catch validation errors at that boundary. Fourth, log the raw response, the error summary, the prompt version, and the model name. Fifth, return no object on failure. Do not partially continue. Bad data caught at the boundary cannot spread. Imagine a ticket router. The model reads a support message and returns category, priority, confidence, and an optional reason. Your schema says category must be billing, bug, or other. Priority must be low, medium, or high. Confidence must be a number from 0 to 1. Cross-field rule: if priority is high, reason is required, because a human will see that reason in the queue. If the model returns category refunds, reject it. If confidence is 92 instead of 0.92, reject it. If priority is high with no reason, reject it. Then log those failures. They tell you exactly where the prompt is unclear. Validation is not magic. A response can pass the schema and still be semantically wrong. Billing might be chosen for a bug report about invoices because the message is ambiguous. The schema protects your system from illegal shapes, not from every bad judgment. Another pitfall is automatic repair loops with no limit. If parsing fails, asking the model to fix its output once can be reasonable. Asking forever creates the loop from the opening. Set a small retry count, then escalate or return a safe fallback. The trap most tutorials skip: if you never measure rejections, you cannot improve the prompt or schema. This belongs in the agent harness, not as a nice-to-have afterthought. The harness is the code around the model: goal, role, tools, permissions, state, and termination rules. Validation sits between the LLM call and everything else. Before tool calling, validate the proposed tool name and arguments. Before memory writes, validate what is being stored. Before state transitions, validate the next state. This also connects to structured outputs, which we will keep using. The model may be asked for structure, but your code decides whether that structure is acceptable. Try this safely on your own machine. Create a small task decision schema with action, confidence, and notes. Action is reply, ignore, or escalate. Confidence is 0 to 1. Notes is required when action is escalate. Now make 5 raw strings by hand. 1 valid JSON object, 1 with broken JSON, 1 with action set to maybe, 1 with confidence at 2, and 1 escalation with no notes. Pass each through your parser. Print accept or reject with the validation error. No external systems, no tools, no accounts. Recap. First, model output is untrusted input to the rest of your system, just like a public form submission. Second, Parsing is not validation. Check types, ranges, enums, and cross-field logic before the data touches tools, databases, memory, or state. Third, reject early and log every rejection, because rejections are a map of weak prompts, missing constraints, and real user edge cases. In the next Agent Foundations episodes, we will connect this to structured outputs and tool calling. New Agent Foundations episode daily. The paid libraries at eyeslabs.ai go deeper with production-ready patterns.